So rational functions are in form of R of x equal to P of x over Q of x, where P of x is a polynomial and Q of x is a polynomial. For example, R of x equal to 5x cubed plus 8x squared plus 9x plus 1 divided by 8x to the power 4 plus 9x cubed. So this is a rational function. We have x at top, x at denominator. And so at the here is polynomial. Also denominator is polynomial. Therefore, R of x is a rational function. Anytime we have x on the denominator, we need to say that denominator cannot be 0. So R of x is, like I made it to a standard form of polynomial here, another polynomial here. For the long run behavior, I mean, when you graph it in positive infinity and negative infinity, this polynomial will we only consider about the first term of top and bottom. For example, this example, for the long run, for the goes to positive infinity or negative infinity, we only care about 5x cubed over 8x to the power of 4. All right. So it's very important. I mean, we ignore all the other one. For the short term, so if you, for the short run behavior, we need to be careful about the zeros and vertical asymptotes. So if you want to graph a rational function, again, you have a calculator, you can just use a calculator and graph it and see how does it look like. But with other calculator, you should find all the zeros of a rational function, vertical asymptote, and horizontal asymptote, which I go over this today. Example, f of x equal to x plus 2 over x squared minus 1. So my question is, I mean, this function is a rational function or is not a rational function? X plus 2 over x squared minus 1. Is this a rational function? So the definition of rational function was that we should have a polynomial and polynomial. X plus 2 is a polynomial. X squared minus 1 is a polynomial. And definition of polynomial was that the exponents should be integer. I mean, this is integer and this should not be negative. So this is yes. Another example, g of x equal to 4 to the power of x plus 3 divided by 3 to the power of x minus 1. Is this a rational function?
No.
Very good. This is not a rational function because 4 power x plus 3, this is not the polynomial. Again, polynomial, p of x should be a x to power n plus a n minus 1, x to power n minus 1. The x should be the base and n the exponent should be an integer. So here we have 4 to the power x. This is an exponential function. So that's not a rational function. What about h of x equal to radical x plus 1 over x plus 1? Is this yes or no?
Yes.
Yes. So this is x to power 1/2 plus 1 over x plus 1. 1/2 here, we have problem. 1/2 is not an integer. So this is not a rational function because we have radical x. Polynomial, the exponent should be an integer, positive integer. N can be 0, 1, 2, 3. So now they're asking us find the line determine the long run behavior of the rational function. Question is f of x equal to 5x to power 4 plus 8x cubed plus 2x minus 1 divided by 20x to power 4 minus 8x cubed minus 5. So they're asking us to determine the long run behavior. So in one of the video that I posted last night, if we have a polynomial, for any polynomial like p of x equal to an x to power n plus an minus 1 x, the long run behavior, we only look at the first term, the highest degree. That means limit of this as x goes to positive or negative infinity, it will be same as limit of this as x goes to positive minus infinity. And for rational function, we just learned that for the long run, if long run means you need to tell me what is the limit of f of x as x goes to positive infinity, and what is the limit of f of x when x goes to negative infinity. That's what they're asking us. So we just pick the first term. First term, that means your has to be in a standard form. If 2x was first, you need to rearrange them. Highest degree should come first. So this is same as 5x to power 4 over 20x to power of 4. X to the power 4, x to power 4 cancel. The answer is 5 over 20, which is 1 over 4. So this is 1 over 4, and that's 1 over 4. So as x goes to positive or negative infinity, f of x will go to 1 over 4. And this is a horizontal asymptote. Any question here?
So both negative infinity limit and positive infinity limit are the same?
In this case, yes, because there is no x here to plug the positive negative. And this, so asking the long run behavior, this is exactly same as horizontal asymptotes. If I ask you what is horizontal asymptote, you need to talk about the infinity and negative infinity. Another example, g of x equal to 3x to power 4 plus 8x divided by 2 x to power 5 plus 8x. So for, again, either I can ask you guys what's the long run behavior, or tell me what is the horizontal asymptote. Horizontal asymptote or the long run behavior, we are looking for limit of g of x when x goes to positive infinity or x goes to negative infinity. We only look at the first term, 3x to power 4, 2x to power of 5. So this is same as limit of 3x to power of 4 over 2x to power of 5. This is same as limit of x to power 4, and this will go away. If you cancel it, x to power 4, and you're going to have 3 over 2x. X goes to plus infinity. What do you think the answer will be? If x goes to infinity, what's the answer for this one?
Is it 3/2?
No.
0.
Very nice. X goes to infinity. That means the denominator is going to be huge number. That's going to be 3 over 2 over 50 million. Correct? If you use a calculator, a number of, if the denominator gets bigger, this will go to 0. Right? So the horizontal asymptote here is y equal to 0. Also, if it goes to negative infinity, again, we're going to go to 0. Y equal to 5x to power of 8 plus 8x to power 9 plus 1 divided by 3x to power of 5. What is a horizontal asymptote for this question? Horizontal asymptote or the long run behavior? So in order to find the horizontal asymptote or the long run behavior, we only look at the first term, which is 5x to power 8 divided, divided by 3x to power of 5.
Is it not the term with the highest degree, or is it just the first term?
Very nice, Megan. I forgot what I wrote. So before you find the first term, you need to make sure is standard form. The top one, we have to write 8x to power 9 plus 5x to power 8 plus 1 divided by So 9 is standard form, thank you. We look at the first term, which is 8x to power 9 over 3x to power of 5. So we need to find the limit of 8x to power 9 over 3x to power 5 as x goes to positive infinity or negative infinity. What do you think the answer will be? If I simplify the x, I get 8x to power 4 over 3 by subtracting the exponent. As x goes to infinity, what do I get?
Is it infinity?
Very good. So the answer here is infinity, and we don't have a horizontal asymptote. So there is no horizontal asymptote for this rational function. So if you
How
back,
did you get infinity?
because when you, so we're gonna have x goes to infinity, correct? Here it said x approaches infinity. For example, x gonna be 10,000. If you plug 10,000 for this x and 10,000 to power of 4 is a big number, right? If x goes to 100 million, so 100 million to power of 4, they get huge. So we're gonna say as x goes to infinity, the answer will be infinity as well,
Okay.
right?
Yes.
So in the last 3 examples, the first example was here. When they have a same exponent, look at top and bottom, they both of them same degree. We had a number was 1/4. This example, the denominator was more than the degree on top, then we had 0. And last example, the degree at top, it was more than denominator. We had no horizontal asymptote. So we can make a formula here for f of x equal to a n x to power n plus a n minus 1 x n minus 1 and b m x to power m plus b m minus 1 x. If we have a rational function like this, for horizontal asymptote, I mean, if you, for example, we have a graph, this is a horizontal asymptote, for example, talking about horizontal asymptote. If degree on top and bottom, they are same, if n equal to m, in our example was 4, then y will be a of n over b of n. We take care of, we get the coefficient. This divide by that. That's the horizontal asymptote or long run behavior. Do you have a question, Benaz?
No.
Okay. If n is more than m plus 1, I'm going to say, like this example, that n is more than denominator, then there is no horizontal asymptote. All right. If n less than m, then horizontal asymptote is y equal to 0. So this makes it very simple. Here I said n should be m plus 1. Has to be more than 1 degree. Why is that? In calculus, you guys are going to learn, for example, y equal to 5x cubed plus 3x squared minus 5x plus 1 divided by 3. I'll put this one 15. 3x squared plus 8x squared. Let's say we have a rational function like this. And in your note sheet, we talked about if n equal to m, if n greater than m plus 1, and if n is less than m, correct? Here there is no, this is y equal to 0, that's y equal to a over b, the coefficient. But in this case, exponents is exactly 1 than degree of denominator. If we do our rule, if we say this is equal to the leading, we're going to have 15x to power 3 over 3x squared. This and that will cancel. 15 over 3 is 5x. We have 5x left. So in calculus, we're going to learn that we don't have a horizontal asymptote, but we have a line, they call it oblique, is like this. For example, the graph will be something like this. But not this course, not in my course. Just keep in mind that the question that you're going to see in exam is like this. You don't have n equal to n plus 1. We don't have a oblique line. Any question? Okay. Example. X, Y. So this is horizontal asymptote at y equal to 2. This is -4. Vertical asymptote. And our graph is something like this. All right, so this is f of x. My question is, what is limit of f of x when x approaches -4 plus? So the plus sign at top, it tells us you should start from positive direction. What is the answer?
Negative infinity.
Very good. So we are going from positive direction. We would like to go to -4. When you get to -4, the graph takes us to negative infinity. So the answer is negative infinity. Now if I ask you guys, what is limit of f of x when x goes to -4 from negative direction, what's the answer?
Is it 2?
So we are going to -4, correct? But from this direction. For example, you are with the scooter, you're going this way. You're going to -4. Now look at the graph. Graph wants to go to -4, but it goes up. It goes to positive infinity. That means you're going to be on the graph. You're sitting on the graph, and you're going to -4, but the graph never going to take you guys to -4. It will take you guys to positive infinity. Same thing we did here. We were on the graph, but from the right direction. We were trying to go to -4, but the graph takes us down. This will be question on your final exam. It's very simple if you know the concept, and you need to know it for the next year to read the graph. Now, what is the limit of f of x when x goes to positive infinity?
Two.
Very good. So we are going to positive infinity is here. So I'm not gonna start from negative infinity to go to positive infinity. I will start the graph from here, and I'm gonna just walk to the infinity. If I go to infinity, this horizontal asymptote tells me this graph never gonna touch me, but in infinity it will touch. So this is gonna go to 2. Also goes to negative infinity, we're gonna hit 2. Any question? So for the short run, for the rational function, for example, f of x, y equal to x minus 4 over x squared minus 9. So you see a rational function, polynomial. Long run, you already know, same as horizontal asymptote. You just look at the degree. This degree is 1, that degree is 2. So what is a horizontal asymptote? Jonas, what's the horizontal asymptote here?
Is it 0?
Very good. So we said if n is less than m, y equal to 0. I mean, you can just use this cheat note, or you can just use the coefficient. So as limit of this is same as x over x squared. X over x squared gives us limit of 1 over x. Now x goes to infinity. The denominator gets huge, then this should go to 0. All right. So now that's the long run. I mean, if you want to graph it, the graph at y equal to 0, I mean, this is the graph. That's the horizontal asymptote, y equal to 0. For the short run, we need to find the vertical asymptotes. Vertical asymptotes comes from the denominator. You make x squared minus 9 equal to 0. You get x equal to plus minus 3. So x equal to 3, x equal to -3 are the vertical asymptotes. Right, this is +3, that's -3. Those are vertical asymptotes. Graph never ever gonna touch the vertical asymptotes, but some graph touch the horizontal asymptote. So don't get surprised if the graph touch horizontal is okay, but not vertical. So you find horizontal, you find vertical. Now the last question is, what are the zero? For what value of x, y equal to 0? So this y equal to 0 is very important only when the top equal to 0, only on here. So you say x minus 4 equal to 0, then x equal to 4. At x equal to 4, at x equal to 4, the graph touched the x-axis. Graph touched the x-axis. What is y-intercept? So now you can use a calculator to graph it, or you can just find the y-intercept. Y-intercept, if x equal to 0, it will be 4/9. For example, 4/9 is there. But then the graph might be something like this. So why did I pick like that? So you know vertical asymptote, you know y-intercept, then you can pick point. For example, put x equal to 1. See, what do you get when x equal to 1? Then y will be 1 minus 4 over 1 minus 9. It gives us -3 over -8, it will be 3/8. Then you say x equal to 2, what is y? So this much will be short run, zeros and vertical asymptotes. Let's have the last example. So let's go over the homework now. And then one of the homework question is 11.2. Number 2. So the question is, find, so this is chapter 11, section 11.2, number 002. Find a polynomial function. So we are looking for polynomial function, f of x, with a single term. So that means should be a x to power n, correct? They call it monomial that satisfies the following condition. So a single term, also f of negative x should be f of x, that means is even. The exponent should be even. And the last condition is limit of f of x equal to 0 as x goes to infinity. So single term, we made it like that. Even function has to be like f of x can be a x squared, for example. That's even, or x to power of 4 or 8. But they're saying f of, when x goes to infinity, the value is 0. So, but for this example, if x goes to infinity, infinity squared will be infinity. So it will be a huge number. In order x goes to infinity, f of x goes to 0, this should be on the denominator. So that should be, so f of x should be a over x squared.
Will this question be on the final?
I'm not done yet. Is that difficult? But
Sorry.
yeah, okay. Yeah, and you're not gonna have question like, but I will. You need to understand what I'm doing. That's the homework. It's not gonna be question like this in final, no. But you need to understand what. I mean, homework means you need to spend a couple hours to solve it. You understand this one. You understand this one. So we try. So therefore, x should be on the denominator. So far should be something like this. I picked 2, I picked x squared, but you can say x to the power 4. That's fine as well. Also, we have one more condition. They said f of 3 equal to 7/8. So with this information, we are able to solve for a. Good. And we have the last part, the degree of f of x has minimal absolute value. So part D, they said, has to be degree 2, has to be the minimum value. You cannot put 4. It's okay, but they made it easy for us. Minimal absolute value. So as 2 is okay. So with this information, if I put 7/8 equal to a over, instead of x, I put 3 squared, I should be able to solve for a. 7/8 equal to a over 9. A will be 63 over 8. So we solve for a, and we have n, which is -2. So final answer will be f of x equal to 63 8 x to power -2. And does that make sense? Are you guys there or just left? And it is okay?
Did you get -2 from fx negative from the
So,
function above?
yeah, they said f of -x should be f of x. That means f of x can be x squared, can be x to power 4, x to power 6, x to power, has to be even. For those, if I plug, for example, f of -x, x squared same as -x squared. X to power 4 is same as -x to power of 4. So all of them gives us same function, is even. Another homework question is 11.5, 34. Very good question. I was looking for this. This will be your final question. This one, you should know it. And you need to know this. Previous question, I agree, is too much to take it in final. But this is something that you can do it quickly and looks kind of complicated. So we have -5 So y equal to -5, horizontal asymptote. We have x equal to -5, vertical asymptote, and x equal to 10, another vertical asymptote. They're asking us, and I give you, and we have a graph. This is -10, -15. So we have a graph like this, and they're asking us what is the equation of this graph. So we are dealing with rational function, correct? We are dealing with r of x equal to polynomial over polynomial. This so this is a vertical asymptote. We learned that we get the vertical asymptote from the denominator. So I'm going to put x plus 5, x minus 10. Where did I get this of this line? This is x equal to -5 and x plus 5. We have this point is x equal to 10. So this used to be x minus 10. So if I make x minus 10 equal to 0, I will get x equal to 10, and this will be my vertical asymptote. What else do we have? We have x-intercepts. Correct? This was x equal to -10. That means we have x plus 10 on the top because we get 0 on the top. Then here we have this point is x equal to 15. This is 15. Then we have x minus 15. Correct? So pretty simple. I mean, you vertical asymptote, you put on the denominator, x-intercept, you put it here. But the only problem is that we need to solve for a coefficient here. Because from this point, we can have different type of graph goes, correct? How do we find the unique graph that they ask us? We pick another point like this one. This is y-intercept. Y equal to -15. So we use that. So -15 and x equal to 0. We're going to say -15 equal to, this is y, -15 equal to k, 0 plus 10, 0 minus 15, 0 plus 5, and 0 minus 10. So this is equal to k. Please stop me if I don't make sense. So you solve for k. 5 and 10 is 2. This and that is gone. So k equal to -5. So the final equation will be, we just need to put -5 here, and you're done. Most likely you need to put it in order. we have -5, x minus 15, x plus 10, divided by x plus 5, x minus. No, it's same, it doesn't matter. This will be the equation for that graph. Any question? We have another homework, 11. I could done that. I didn't, for the previous question, I didn't use, I mean, there's a cheating way to use the horizontal asymptote. Y called -5. Instead of using this point, in order to solve for k, correct? Because they have a same degree, we have x squared at top, x squared at the denominator, then horizontal asymptote is -5. That means k must be -5 because its coefficient should be -5/1 or -5. That's another way to do it.
Why is it -5 and not 5?
Did you get, so from, I mean, from the horizontal asymptote? For my algebra here, did you get +5?
Yeah, I got +5.
I mean, one way we can do it through the horizontal asymptote, but let's do this back to this formula here. So we have -15 equal to k, 10, -15, 5 times -10, correct?
Oh, okay, sorry, I got it now. I just forgot why it was -15. Thank you.
Okay, good. So another homework question, 11.5, number 36. This is same type of question. I give you guys a graph. The graph has two vertical asymptotes, which x equal to -6, x equal to +6. There's a 2 here, like that, like this, and like that. This point is 72. So x equal to -6, x equal to 6, a vertical asymptote. That means on the denominator we have x plus 6, x minus 6. All right. This point is x equal to 72. That means we have x minus 72 on the top. Cool. So we are done. Only we need to solve for the k. One way to solve for k, looking at the horizontal asymptote, this one, which is y equal to 0. We get y equal to 0 when the exponent on top is less than denominator, which it is. The top is 1, the denominator is degree 2. Let's say if you didn't see the horizontal asymptote, we pick this point. So we're going to say this point is 0, 2. 0 for x, 2 for y. You get 2 equal to k, 0 minus 72, 0 plus 6, 0 minus 6. So 2 equal to k times 2. 72 divided by 36 is 2. So therefore, k equal to 1. So this is 1. So this will be your final equation. All right, guys, let's, so this 2 was, I solved 3 homework questions. Before I hand it to other people to present, for tomorrow, I will email you guys if we're going to meet at 8 a.m. or 9 o'clock or 9:30. So I will give you guys a new link if happening on the 8 a.m. I made the final exam. There are 20 questions, and I'm going to go over the 20 questions tomorrow through the video. Not exactly same questions, similar question. I'm going to solve it for you guys, and then you guys going to practice it and take the final. All right. Question?
I have a question on chapter 11, 11.2, question 18. Mm-hmm.
This is, did you try to solve it?
Huh? Yeah. I don't know what's terms. I know polynomial is 5, but I don't know what's term.
Terms, and how many, we have y equal to 5x to power 5 minus 5x to power 4 plus 4. They are 1 terms, 2 terms,
Oh, okay.
3 terms. The degree will be this guy. Degree is 5.
Okay.
All right.
How about chapter 11, 11.330? I think I write it down. I don't know whether plus make me write or not. I don't know.
What?
Chapter 11, section 11.3, question 30. With 3 point, find a.
So we have a graph. So this is 11.3, number 030. This is 8. This is negative 8. This point is negative 8 as well. This is actually a good question. So we have, they're asking us what is the equation of this graph. So we have a polynomial. Looks like a chair, but so definitely this is not a rational function. You should be able to differentiate. This is not rational because we don't have a vertical asymptote. Rational function has a vertical asymptote. You don't see any dots. I mean that. So this is x equal to negative 8. This is x equal to 8. This is y equal to negative 8. All right. So we are looking for p of x equal to, this will be x plus 8 multiply. This has a multiplicity of 2, will be x minus 8 squared. Anytime the graph touches, so when you see the graph, you should know this is a polynomial of degree 3. It looks like a chair. 1 point is here and 2 points are there. This is 2 points. That means x equal to 8, x equal to 8. It touches. So the only things left is a number here, which I'm going to put at k. You have to solve for k. How do you solve for k? From the y-intercept. So you're going to say -8 equal to k, 0 plus 8, 0 minus 8 squared. You solve for k, then you will plug it back. You should be able to do that. All right, guys. So, Megan, do you want to go first for the presenting?
Yeah, sure.
Thank you. So you can share. You can share your screen. Stop sharing. Whew.
Okay.
Polynomials, nice.
So I'm Megan, and this is my presentation about polynomials. So the rules of polynomials include that the degrees of variables must be positive integers, and the terms are based off of the formula a times x to the power of n, where a is a coefficient, which is multiplied by the variable x, and then the variable is raised to a non-negative integer power. And there are usually several terms in one polynomial expression, but there are also subclassifications like monomials, binomials, trinomials, etc. And when asked what the degree of a polynomial is, the answer is the highest degree on one of the terms in the polynomial. And polynomials are written in descending order of degrees. So the basics of graphing include each term's degree will determine whether that part of the graph is linear, quadratic, cubic, exponential, etc. And the graph will then bounce before returning to the next term. So in this example, this term has an exponent of 1. So the x-intercept is -2. And then the exponent of 1 means it's linear. So there's a line going through the x-intercept of -2. And same with this term, the x-intercept is -1 and it's linear. So there's a line going through it. And then this term is cubic, so it has an x-intercept of 1, and it is a cubic shape going through it.
Very nice.
Thank you. So the basics of graphing also include, there are 4 options that you can choose from for each formula, and these are based off the leading coefficient and leading degree. So in this example, the leading coefficient is 10, and the leading degree is 7, and the leading degree is always the highest degree, and the coefficient is the number connected to the highest degree. So for this example, the coefficient is 10, which is positive, and the degree is 7, which is odd. So this would be option 2. So this means that the graph, the left side is facing down and the right side is facing up. So for step 1, like we said before, we're going to check the degree signs and if they're linear terms or quadratic or cubic. So there is a linear term, and then cubic. And this means that the graph will be left side facing down and right side facing up. So for step 2, we're going to draw a sketch of the graph, and we're going to plot the x-intercepts. So in this case, the x-intercepts are -2, -1, and 1. So we plot them right here, and then we plug in 0 for x and find the y-intercept, and in this case, it's -2. And then we're going to put lines through the linear terms and then a cubic shape through the cubic term. And for step 3, we're going to connect each of the lines or curves with a bounce. And usually this is estimated, but since we have the y-intercept, this bounce will go through that. And we'll end it with the degrees, or with the directions that the graph is facing. And here's some more examples. These are some formulas of polynomials, and this is a polynomial because this is technically saying 10 times x to the power of 0. And here's some more examples of graphs. And these are my resources.
Excellent. Very nice. Nicely done. Much better than me. All right, Ella. So you can stop sharing your screen if you're done. Then
How do I
go to
do-
Zoom.
it won't let me.
So I should be.
Weird. Are you able to like stop my?
Sure. How do I do that?
Hmm.
Is it good?
Can you still see my screen?
No, but we don't see your screen anymore. Ella, can you share your screen?
Yeah. Mhm. Okay, mine presentation is going to be how to find the simplified formula for the difference quotient. So when you get your problem, like either on the test or like in your homework, they'll give you this kind of formula, which is f of x plus h minus f of x over h. And then they'll give you like another formula, which is just f of x, or a formula of f of x. So for this example, it's x to the second power plus 5h. So the first step you want to do is replace the x values in f of x with the ones from the formula. So an example of this would be you would take f of x and put that into f of x plus h. So over here, I took this formula and replaced the x value with x plus h. So then I just plugged it into the whole formula so you can see that out over there. So the second step is to expand and distribute that part, because right now it's not simplified. So you just need to expand it and simplify it. So I got x to the second power plus 2xh plus h to the second power plus 5x plus 5h. So that's the whole thing just simplified out. And the next part is to subtract f of x from the problem. So basically we only did this first part over here, which is f of x plus h, but you need to still do the second part, which is subtracting f of x from the problem. So over here, I just added to the end the subtraction of f of x, which is just the whole f of x problem again. So for the next part, you have to combine the like terms. So I just put all the terms and written out. I had to distribute the negative number, the negative symbol, so I distributed it out, and it was positive before, so now it's negative. And then you combine the like terms. So the ones in red, so the x to the second power and the negative x to the second power, they can cancel out. So can the 5x and the negative 5x, so you can remove those values from your expression, and then what you're left is what's there. So then you have to rearrange what you have left. So I have 2xh plus x to the second plus 5h. So you just have to rearrange what you have left over and put it over h. So when you do all of that, you have h to the second plus 2xh plus 5h all over h. So that's what happens when you rearrange it. So then you can divide by h and just cancel out the h's that are left over, so you have it in the simplest form. So if you do that, your final answer is going to be h plus 2x plus 5. So that's one example of this type of problem. Another example would be something like this. So this uses the same exact formula. It's just f of x plus h minus f of x over h, but this one has 7 to the x power, so you do it a little bit differently. So you're going to start with the same steps to replace the x values in f of x with the ones in the formula. So I just replaced the first part, or the x in this formula, or this equation over here, with x plus h. So that's what I got in the red over there. And then after that, you will subtract f of x from the problem, because you can't really distribute anything after that or simplify anything further. So you just have to subtract 7 to the x power from the whole equation. And then finally, just divide it by h to simplify everything, you can't really do anything further, so that will be your final answer. So this is another example of a type of problem that uses this formula. And then I have another one that has more like values in it. So this one has a 4 added to it and then a -2 added to the front. So it has a little bit more steps in between it, but they all follow the same kind of pattern. So you first replace the values in x. So I just replaced the values of x and I added x plus h to this formula. And then it has a little bit more steps in distributing and expanding it because there's more like sections to work on. So first I FOILed this middle part. So I expanded that and I got x to the second plus 2xh plus h to the second. And then I put the 4 on the outside because I still have to distribute that out. And then I have -2x plus h. So I expanded the whole thing out. I made sure to distribute the negative, the 2, and make sure to flip the sign so it matches up with everything. So I just expanded everything, and that's all I have to do for the expanding and distributing part. So I remember, once again, I only did this first section here, so I still have to subtract the f of x from the whole problem. So I added that part on the end from what we had before. So I just subtracted the f of x section that I just added to the end. And you have to combine the like terms. So I just distributed everything, make sure to flip the sign once again, make sure everything is looking the same. And then I combined the like terms, which is written in the red and orange. So the red cancels out each other and the orange cancels out each other. And I'm just left with 8 x of h plus 4h plus, to the second power minus 2h. So you rearrange all of that and put it in order of the powers, and then you divide it by h. So then finally, for the last step, you just have to combine everything together. Make sure you divide the h so there's no more h where there doesn't need to be. And the final answer is 4h plus 8x over 2. So that's it.
Very
Thank you
nice.
for listening.
Excellent. So it was great. So 3 example for the using quotient. So I don't remember the name of formula, but for sure you will have a question like this in the final exam. I'm not going to give you guys exponential function that Ella was in the her second example, but you will see a quadratic like a last example that she made. Very nice, excellent. When Paul was Paul, yeah.
Yeah, give me a sec. Okay. So yeah, I'll just be presenting on like intro to polynomial functions.
Very nice.
Understanding them.
Very nice.
So so for family of polynomial functions, general formula for the family of polynomial functions, general formula for the basically the general formula is written right here. So we went over this earlier, but it's p of x a to the n. It's kind of hard to explain, but kind of see here. So that's like just the general formula, and just describing like the understanding the different terms within this formula. So where n is positive integer, it's called the degree of p, and a to the n cannot equal 0. So each member of the sum, a to the n, x to the n, and right there, the term. So basically each one is called a term. And the constants, a to the n and a to the n minus 1, a to the 0 are called coefficients, basically what's in front. The term a to 0 is called the constant term. And the highest powered term, a to the n, x to the n, is called the leading term. And we had like multiple problems with that earlier. And to write a polynomial in standard form, we arranged its terms from highest power to the lowest power, going from left to right. So like not all questions will be like given from highest to lowest, but sometimes we have to rearrange the terms in order to get from the highest power to the lowest power for some of the questions. So to continue. So as we were talking about also earlier, based on different n values and the degrees, these are the like 4 of the main different graphs. And the graphs of polynomials do not contain any horizontal or vertical asymptotes as they are smooth and unbroken. All these graphs are based on the result of what the degree is. So basically, when it comes to graphing, these four will just be like a reference key. It would be like good just to have like notes of these, just so when you graph and you won't get confused or get mixed up. It's based on the degree level.
Okay.
So here are a couple example questions for basically like understanding some of the polynomials. And so for these, we're basically determining if these are functions. And then we're determining the degree, the leading coefficient, and the constant term. It's a little hard to see here, just this, but f of x equals to 3x squared plus 4x to the third power plus 2x to the negative 1 power. So just starting with that, basically what's important to look is, since the last term, which is 2x to the negative 1 power, since it's raised to the negative 1 power, this function is not a polynomial, basically just due to the last term being negative 1. So we can't have any negative degrees basically in our function. So based off of that, it's not a polynomial. So for the second one, g of x is equal to x squared plus square root 2x to the third power plus 1. So the key to look at, the highest term is, it's kind of hard to tell with the square root here, but basically within the square root is 2x to the third power. So since it's raised to the third power, that's the highest degree. So our degree would be 3, and the leading coefficient, which is 2x, but 2 is basically the leading coefficient is before the basically before the term is the highest. So it's 2, and the constant is basically, for this one, it's at the end. It's usually at the end sometimes, the constant, yeah, so for this one, it would just be plus 1, basically, or just 1.
Okay.
So for h of x, it's equal to, so this one is a little bit different because it's not, it's in like factor form, so we basically have to just like factor it out. So we have 2 parentheses x plus 5 parentheses x minus 1 squared. Basically, like I didn't really have time to just like show you guys how to do it, but we worked it out basically, and it's 2x to the third power plus 6x squared minus 18x plus 10. So so for the leading coefficient, which is basically in the front, we have it's equal to 2, and and then since the highest degree is 3, as you can tell, the 2x to the third power raised to the third power. So 3 would be, it would be to the degree third. And then for the constant term, which is basically at the end, it would be 10, where we would see plus 10. And that's just basically just like the basics of understanding functions and just determining the polynomials and what to the degree coefficient. So yeah, that's just it.
All right, Paul, thank you so much. That's great. That was a very good review. Do we have anybody else? Or, oh, sorry, Benjamin. Yes, go ahead.
Okay. Okay. So I wanted to do how to find the zeros of a polynomial function.
Very good.
So just to start off, this is probably the easiest form you'll have to work with. It's already factored out, so we can automatically find the zeros just by looking at what's inside the parentheses, which are 3, -2, and 7.
Very good.
So that means the zeros will be -3, 2, and -7. This one is a little bit harder. In this case, we need to take steps to factor it. So the first step is to find a common factor, and in this case, it will be x. So we get the resulting equation, which is x, open parentheses, x to the power of 2 plus 7x plus 12. From there, we can start focusing on the equation inside the parentheses. We can factor it out like normally. So in this case, 12 can be factored into 3 and 4, and that equals 7x. So we get x plus 3 times x plus 4. So this introduces a new thing, which is the x on the outside of the parentheses will always equal 0. So the zeros of this equation would be 0, -3, and -4.
Very nice.
So what happens when we get a problem like this? We can split it into 2 parts and work on them separately. So let's break it up using the parentheses. So the first problem, which is x squared plus 2x minus 7, we can factor it out by completing the square, which is seen on this side. So x squared plus 2x minus 7 can be rewritten as x squared plus 2x equals 7. Now to complete the square, we factor this out and we add a 1 here. That ultimately gives us x plus 1 equals the square root of 8. So eventually we get -1 plus the square root of 8 and -1 minus the square root of 8 as the zeros for the first part of the problem. Now the second part, we need to do what we learned before, which is to factor out the x. So we get x times x squared plus 4x minus 21. So 21 can be factored into 7 and -3. So we get x times x plus 7 times x minus 3. So remembering that the x on the outside of the parentheses means that there's a 0 at x equals 0, the remaining zeros for this equation are -7, -3, and 0. And yeah.